Hello and welcome. In the last part of the 7.4 notes, we're going to look at a particular integration technique that ends up giving you partial fraction kind of problems. And this is just one more technique that can help you out sometimes in your bag of integration techniques. So as it says, if you have the integral, an integral that has the square root of something in it, you might try letting u equal the square root of that something. Sometimes this helps get rid of the square root problem and give you an integral that doesn't have a square root in it. I mean, that was the key to trig substitution, where you do a special trig substitution and it eventually collapses the square root. But here is just another way to get rid of square roots inside of integrands. So in our example 6, we're looking at the integral of the square root of x plus 1 over x. And as a first step, we're going to try letting u equal that square root of x plus 1. Let's write that over here. U equals the square root of x plus 1. Now the du involves taking the derivative of this square root, and it's not too bad. You just have to rewrite the square root as a half power, right? X plus 1 all raised to the half power. The half multiplies in front. You subtract 1 from the exponent to get negative a half. And then don't forget to multiply by the derivative of the inside, which in this case will just be 1. And at the end of the day, when the dust clears, you get du equals 1 over 2 square root of x plus 1 dx. Now, one thing to notice is that we don't have a square root of x plus 1 in our integrand. So it doesn't seem to match what we have here in our integrand. But that's okay, actually, because in this case, we have the square root of x plus 1 was our original u. So if we go and rewrite this, we can write 1 over 2u dx. And move the 2u over to the left side. So we get 2u du equals dx. Now by doing this, we'll be able to replace the dx without having to have another function right next to it, like we normally do with substitution. So now with our substitution, we can write, oh, and there's one more thing we need to do, which is replace the x here. So we can solve this one for x. We'll write u squared equals x plus 1, so x equals u squared minus 1. So we can replace everything in our original integral. Let me switch over to blue. We'll get the integral of, so the square root of x plus 1 is u, over x right here is u squared minus 1. And then dx is 2u du. Okay, so now we have everything written in terms of u. In order for the substitution to work, all the variables have to change into your new variable. So we've got all the x's, including the dx, turned into something involving u's and du. Now when we simplify this, we'll end up getting something like, we can pull the 2 out, and we'll get u squared over u squared minus 1 du. And if you look at what we have inside, we've got a rational function inside. So we can start to think about using the partial fraction technique. But before we start breaking it down, there's something that we have to do first. Do you see what we have to do? We have to divide first, because the degree on the top is bigger than or equal to the degree on the bottom. In this case, they're equal. And even when they're equal, you want to do long division first. So we're going to do long division off to the side. Choose a different color. U squared divided by u squared minus 1 looks like this. U squared divided by u squared is 1. 1 times u squared minus 1 is u squared minus 1. Subtract down, we get a remainder of 1. So then pulling it together, we end up with, let me scroll down a little bit, 1 plus 1 over u squared minus 1 du. Okay, Now we can work on partial fraction decomposition for the 1 over u squared minus 1. But first, we have to factor the denominator. So we'll go ahead and factor the denominator. Actually, you know what? Let's take this off to the side here. So I'm going to pull this partial fraction decomposition problem off to the side in a different color. We have 1 over, and I'm going to go ahead and factor it. So you know what? Let me write this in steps here. So we have 1 over u squared minus 1 equals 1 over factored. We're going to write u plus 1 times u minus 1, which breaks down into two fractions, one for each linear factor, a over u plus 1, and then plus b over u minus 1. Then we would multiply both sides of the equation here by u plus 1 times u minus 1, and we'll get 1 equals a times u minus 1 plus b times u plus 1. Now we can plug in specific values for u to get rid of all the undetermined coefficients except for one of them. So we can plug in like u equals -1, which would get rid of b and just leave us with a. So we get 1 equals -2a, so a equals -1/2. Then plugging in u equals 1, we'll get 1 equals, the a is now gone, and we have 2b, so b equals 1/2. All right, then we can feed the a and the b back into the two little fractions here. And we end up getting, so 2 times the integral of 1 minus 1 over 2 times u plus 1, and then plus 1 over 2 times u minus 1 dx. I'm running out of space there. And at this point we can integrate, whoops, sorry, that's a du. At this point we can integrate term by term. So we get 2 times u, because that's our variable of integration, minus 1/2 ln absolute u plus 1 plus 1/2 ln absolute u minus 1, put a plus c. And the only thing that is left is to go back to x. So going back to x, and also we'll go ahead and distribute the 2 as well. So we'll have 2 times the square root of x plus 1. That's what u was equal to when we first set up the substitution. And then the half and the -1/2 become just -1. ln absolute square root of x plus 1 plus 1, and then plus 2 times 1/2 gives you 1, and then ln absolute square root of x plus 1 minus 1 plus c. Whew. That was fun. Now there's one other thing that I wanted to mention before we leave this problem, which is originally when we let u equal the square root of x plus 1, it took a few steps to be able to find what dx is equal to in terms of u and du. But there's a quicker way of doing this, and I'm going to show you off to the right here using red. So I'll write, or what you could do is once you have u equals the square root of x plus 1, you can solve for x with a couple of steps and then take the derivative on both sides. Because when you solve for x, you're not going to have that square root anymore. In fact, the first step, we're going to square both sides and get u squared equals x plus 1. So we don't have that square root anymore when we go to take the derivative. Now we can subtract the 1 over, solving for x, and then take the derivative on both sides. And on the left side, we'll get 2u du. On the right side, we'll just get dx. So we end up at the same place, 2u du equals dx, that we did before, but without having to go through the radicals that can sometimes be a little tricky. So definitely, if you want to use this method, it's very nice, and I would actually write it out this way if I were doing these problems. Sometimes I'll write it this way with the radicals, but most of the time I'll be trying to write it where you solve for the x and then take the derivative. Okay, so that concludes 7.4. Thanks for watching, and see you next time.